Welcome, folks, to another episode of Space Talks with Z, hosted by the America's Future Series. Thank you all for joining us today. We have an amazing discussion where we're going to be looking at Test Gods, the spectacular new book from Nick Schmidl that looks at how the modern space race has evolved, and in particular looks at some of the amazing people driving it. Today we have with us Nick himself. We've got Tucker Hamilton and Dan Forsich. And I'm going to be part of the discussion today. Ben McNally is going to be leading the discussion. Ben is a senior at UT Austin. He was a fellow at the Clement Center for National Security. And I'm going to hand this discussion over to him now. Thank you and welcome to all.
Hey, thanks, C. It's a pleasure to be here. Hi, everybody. I want to thank you for joining us today. And I'm certainly excited to be joined by four individuals who are uniquely qualified in their own ways to discuss this very, very exciting time in commercial space flight. And to kick off the panel today, I want to go back a few years. On December 13th, 2018, two test pilots flew a spaceship into space from American soil. The spaceship did not take off from Kennedy Space Center, but from an airport in the high desert of California. The two pilots, Mark Stuckey and Rick Sturkow, were not civil servants or military officers assigned to NASA, but private citizens working as employees of a company, Virgin Galactic. After reaching a peak altitude of 51.4 miles, Stuckey and Sturkow guided the spaceship to a safe landing at the Mojave Air and Spaceport, where they were enthusiastically greeted by Sir Richard Branson, the founder of Virgin Galactic. And 10 days ago, Branson joined two other Virgin Galactic pilots and three other passengers on the same spaceship for Virgin Galactic's first fully crewed spaceflight, fulfilling his lifelong dream of going to space. Virgin Galactic is one of several American companies that is giving paying customers who are private citizens the opportunity to fly to space. Yesterday, Blue Origin founder Jeff Bezos and three others reached space in the New Shepard crew capsule, marking the first human spaceflight in the company's history. And later this year, 4 space tourists are scheduled to fly the first private space tourism flight in SpaceX's Crew Dragon capsule. This ongoing revolution in human spaceflight will help to usher in a new space economy that is projected to be worth $1 trillion by 2040. And today, the America's Future Series is honored to have Nick Schmidl, Tucker Hamilton, Dan Javorsek, and Zaheer Ali here to discuss this very, very exciting time in spaceflight. Tucker Hamilton, call sign Cinco, is a colonel in the Air Force and currently the director of the Department of Air Force and MIT Artificial Intelligence Accelerator, where he is helping to solve Air Force and Space Force problems using AI in partnership with MIT. He is a fighter pilot and test pilot by trade, most recently commanding F-35 development at Edwards Air Force Base in California. He holds an undergraduate degree in aerospace engineering from the University of Colorado, a master's degree in aerospace engineering from the University of Tennessee, and a master's degree in flight test engineering from the U.S. Air Force Test Pilot School. How you doing, Cinco?
Doing well. It's great to be here with you.
Hey, great to have you. Next up is Zaheer Ali, who is familiar to all of you. Z is a researcher, entrepreneur, and leader in science and technology. For the past decade, he has worked on NASA contracts at the university's Space Research Association, supporting astronomy, human space exploration, and advanced aviation. And along the way, he co-founded and serves as CEO of Material Mind, a material analytics company, and also co-founded Axia Global, an AI and digital transformation firm where he is chief science officer. He previously worked in the Department of Energy on nuclear weapons and homeland security. He holds a BA in physics from UC Berkeley and a master's in global management from Thunderbird University. Z, can you hear me okay?
Yep, we're all good.
Colonel Dan Javorsek, call sign Animal, is the commander of Detachment 6 of the Air Force Operational Test and Evaluation Center at Nellis Air Force Base in Nevada. He is also director of the F-35 U.S. Operational Test Team. Detachment 6 evaluates the operational effectiveness, suitability, and mission capability of the F-35, F-22, F-15C and E, F-16, and A-10, and reports results in support of major acquisition program milestone decisions and combatant command field decisions. He holds 5 academic degrees, including a bachelor's degree in aeronautical engineering and a doctorate in nuclear astrophysics from Purdue University, and is joining us today by phone because he just completed a flight in the F-35. How you doing, Animal?
I'm doing great. Thanks for having me.
Hey, great to have you. And finally, the man of the hour, Nicholas Schmidl. Nick writes for The New Yorker and is the author of Test Gods, Virgin Galactic and the Making of a Modern Astronaut. His work has also appeared in the New York Times Magazine, The Atlantic, Slate, and The Washington Post. He has been a National Magazine Award finalist, a two-time Livingston Award finalist, and winner of a Kurt Schork Award. He is a former fellow at the Institute of Current World Affairs, the New America Foundation, the Woodrow Wilson International Center for Scholars, and resident at the Rockefeller Foundation's Bellagio Center. Nick, thank you so much for joining us.
Thanks for having me.
So, having spent years of your life working on telling the story of Mark Stuckey and Virgin Galactic, what was your reaction to last Sunday's fully crewed flight from Spaceport America?
You know, it was both a major step for them, a major moral boost, morale boost, because now they've gotten the founder up in the air, right? But in some ways, I think that we've read too much into its long-term commercial impact, when in some ways it was kind of a prototype flight. It was a little bit of a proof of concept that you could load the spaceship up with passengers, you could get to the edges, you could, get into the edge of space, you could get down and, also do it in front of a lot of people with a live stream, which are all things that, they've come under criticism in the past for not having live streamed their flights. And so this was a big moment of kind of candor to letting that live stream follow them. But now comes the hard part for them, because now comes the challenge of doing what no previous human spaceflight provider has done, which is to take that 3% fatality rate and to bring it down to a fraction of 1%, which is what, in order for them to make a viable business of this, they're going to have to do. If 1 out of every 30 astronauts or passengers go up, doesn't come back, they're not going to be around very long. And so now in some ways comes the hard work. But yeah, it was a huge moment for them as a company, for Branson, kind of fulfilling this dream and an opening salvo in this really interesting, back and forth between Branson and Bezos.
Absolutely. And you mentioned the back and forth there. And one of the aspects of that back and forth has been the difference between the US distinction for the boundary of space and the international distinction for what constitutes space. Could you describe that to our viewers and possibly give your own opinions on it, having covered this for a while?
Yeah. There's this artificial line in the sky at which point airplanes no longer operate like airplanes, and you need a rocket to be able to sort of move through space or move through the atmosphere or the upper atmosphere, and that is the 100-kilometer designation of the Kármán line, which was early 60s. American, US, and Soviet scientists came up with this sort of formal designation or artificial designation of what space would be. As you mentioned, the US uses a different designation. NASA and the Air Force and the FAA all recognize 50 miles as their nice round number, which comes to a little over 80 kilometers, whereas the international community, the metric system, uses 100 kilometers. So there is this discrepancy. If you look at the cockpit footage, the still photos and the videos from Virgin Galactic's flight, you look out the windows, it's black. You look down, there's the blue orb of Earth. Stuff's floating, people are floating. It looks like space to me. I mean, I'm really curious actually to see some of the cockpit footage from yesterday's Blue Origin flight, because they flew 70,000 feet higher. They flew 351,000 feet, 70,000 feet higher than Virgin Galactic's flight with Branson 9 days ago. And Blue Origin has made it a sort of a marketing stance that above the Kármán line is a different experience. So I'm actually quite curious to see if there is any qualitative difference in the view or in the cockpit experience. But up until now, I kind of think that it's a bit of a petty squabble, and the scientific community, for what it's worth, there's an astrophysicist at Harvard who wrote a paper a couple of years ago proposing revisiting this Kármán line, revisiting this designation of space, and the organization that the FAI, this Federation Aeronautic Institute or something along those lines, they have openly said that they're in the midst of waiting to hold a conference in which they might reconsider moving the Kármán line down.
Got it.
If I may jump in and ask, we do have an astrophysicist with us on the call today, so maybe we can ask his opinion. Anna, what do you think of that, sir?
Yeah, I mean, I think when it comes down to it, it's always kind of comical to me how we take something that is a, say, continuous distribution and elect to put breakpoints in those, right? I think for the sake of the discussion today, it seems that certainly that's been part of the topic and galvanized the conversation, as well as the exchange between the billionaires, right, on where the line's actually at. I suspect that, you know, for the most of us, you take a picture or just look at the video feed from the Virgin flight, and I think you have a pretty good representation of what most people think of looking out the window. Naturally, there are always going to be debates on where you can say drive the dividing line between those things, and it wouldn't surprise me if the Kármán line ends up getting negotiated. I mean, when I was a kid, I grew up and Pluto was a planet, right? And that ended up changing a few years back, right? So, I mean, I think the point of it is we get kind of wrapped around the axle on, say, some of the semantics of this, but at the end of the day, the accomplishment that Virgin pulled off is certainly something to be celebrated, regardless of whether it's 80 kilometers or 100 kilometers or 50 miles. Just my 2 cents.
Absolutely. Now, Nick, how did your relationship with Lieutenant General Robert E. Schmidl inform your writing on a book about Mark Stuckey, who began his career as a Marine fighter pilot?
Wow, that's a big question. Yeah, my dad is retired Marine Corps general. Rooster is his call sign. You know, how to get into this? I mean, I started spending time with Mark Stuckey when I was working on the book. First working on this magazine piece that then became the book, and I spent a total of 4 years embedded with Virgin Galactic. And there's a bit of, you know, usually by New Yorker, you spend longer on a piece than most other magazines. You 3, 4, 5 months at a time, which is extraordinarily long and generous because you have so much time to kind of figure things out. Well, so I took those 3 or 4 months and I made it 4 years. And typically I also get tired of a story after a few months. And I was kind of interrogating my own motivations for trying to figure out why I wasn't burned out on this story. And part of it, I began to realize had to do with the fact that there was this personal connection. And that in some ways I saw, you know, when I first met Forger, Mark Stuckey, I remember thinking, like, I know the type, right? I mean, I know I've lived with a version of that type for my, 35, now 40 years. And so I think that I could sort of write about Forger in a way that felt intimate. And it also gave me a way to write about my dad without directly writing about my dad, which is always something that I try to figure out, like, how am I going to one day write about my dad? And I just didn't think that I could do it in some ways. Like he's still very much alive. He's flying in an acrobatic air show here in a couple of weeks. And like, he was racing motorcycles in the beginning when I started working on this. He's involved in a number of things. He's a larger than life. He's kind of always cast this huge shadow. And so in a way, both I could write about my dad while not writing about him via Stuckey. And also I kind of felt like I brought this whole wealth of sort of subsurface understanding about what made people like Mark Stuckey or my dad tick because of that family background.
Can I jump in too, Ben? I loved the book. I really enjoyed the way that you wove together this story that is larger than life, commercial space exploration, with the human element and the relationship element that is between a father and a son. It really spoke to me. I have 4 children, 2 girls and 2 boys, and I'm also friends with Dylan, Forger's son, and
Oh, wow.
Forger I've known for many years. So it was really powerful to me because it spoke to something about like how that relationship, they're complicated, how those relationships are formed, how they change, how our pursuits and our passions influence and impact the people around us, because we all have that tension. We all struggle with that. And so I found it really revealing and kind of heartwarming, just reading about their story, and then Nick also reading about your story, how it's in there, and I found that a piece of the book that I didn't expect to be there that I really enjoyed.
Oh, thanks. That means a lot. I mean, I'd wrestled with that because I wanted there to be some sort of twist or turn in the middle of the book. I kind of felt like you had this steady progression of the first third of the book. You're kind of following Forger's career trajectory. And, I often, and this was a concern from Virgin Galactic, when I started writing working on the magazine piece, the folks at the company said, wait a second, you usually write about criminals and, international intrigue, and should we know something? And I was like, no, it's I look for stories that have twists and turns, and there were along the way with accidents and surprises. But, I really kind of spent a lot of time trying to figure out how I knew how to make that personal story germane. I knew that it felt germane. I didn't know how to make it feel germane and not gratuitous to a reader that, this is not just some author kind of tacking on this personal story. So, I'm really elated and delighted to hear that it did resonate. And I think that that's actually all the concern in the past 2 weeks. We've heard all kinds of sniping about, billionaires not reading the room and not understand, being out of touch with what's going on. And for me, the story was always much more about the men and women in the cockpit, turning the wrenches, drawing the designs. And in the case of Virgin Galactic, Branson is very much a kind of detached leader. He's not in the weeds on a daily basis. He's actually legally prohibited from doing so because of the, from ITAR regulations. But it was always a human story, and I wanted to bring that to bear. And I, kind of hope that by investing kind of into humans and the way the story was told, that you would be able to move through the more technical stuff. So those of us who are not as technically savvy with you'd be able to glide through it with some ease. So, yeah.
Fantastic. Now, Nick, in the book, you described the profession of flight test as, quote, not adventurism for its own sake. It was a methodical process that drew as much on the discipline and rigor of the scientist as on the artful improvisation of the daredevil. Now, for our two test pilots here, I want to ask, have test pilots become relatively less dependent on what Nick calls the artful improvisation of the daredevil, as automated flight control systems have eliminated many of the risks that previous generations of test pilots assumed as a part of the job, and how much of that artful improvisation is still required?
I don't mind taking it first, Zenko, if that's okay with you. I've got to go here in a couple of minutes, so. So yeah, I mean, I think there's a lot to unpack there. I suspect that a lot of the automation that we have seen is actually a really good thing, right? Because it really enables us to maybe more accurately put the human at say the appropriate division of cognitive labor within the cockpit. And so there are a whole host of these sorts of things that I think are, in general, a really positive element, but it does take away a little bit of, say, the thrill that most of the pilots get into. And I think it, to feed it into what you see in the space age of the 21st century, you really find that what Forger and CJ and the rest of the Virgin Galactic pilots do, they don't have any of that automation. They are hand flying the spacecraft pretty much through the entire thing. There are a couple of displays that help them with energy management and that sort of thing that they developed back when they were at scale. But really, for the most part, the Virgin guys are about as close to that, I would say, idealistic image that we all have in our brains of what a test pilot and probably even an astronaut would do back many years ago, as opposed to the highly automated systems that you see on SpaceX and Blue Origin, right? Where pretty much everybody is a passenger that's not really a very active participant in the flight control of the vehicle. So one of the things that was kind of interesting to me to look at, especially in the social media space, was there's a pretty open and hearty discussion on whether you call these folks astronauts, given that based on the kind of previous conversation we had about where you draw the line of space, as well as the more that you become kind of a passenger and the less that you take an active role in kind of controlling the vehicle. And so, and to kind of sum things up, I think that a lot of the autonomy that we see put onto to aircraft and really spacecraft these days is a very positive thing, but it does take away some of that element. And I think what the Virgin folks and Scaled & Company really pulled off was a little bit of a nod back to the way that we used to do things. And there's a certain element of nostalgia for that that probably makes it a little bit more fun too. But that's just my 2 cents on it. Over to you, Cinco.
Thanks, Animal. I completely agree. What the Virgin Galactic pilots are doing is what we would consider more traditional historic flight test because it's such an unknown, right? We have been flying in, our part of the atmosphere below, let's say 50,000 feet for so many decades now, developing aircraft and developing a profession behind that. Test gods, I hope the listener realizes is not about a test pilot, right? It is about individuals that are test professionals. And that profession has, one is a huge team sport, right? And there's so many people involved with making that possible, but it relies on a foundation that has been established over decades of us figuring out how do we more safely and effectively and efficiently fly airships, aircraft, and gather data in order to ensure that it meets the requirements, that it is safe to fly. And so, yeah, being a test pilot in 2021 is very different than being a test pilot in 1960, 1970, 1980. Yet, what Virgin did was going to a place that is not known, right? We don't have that same foundation. So it really does speak to an earlier generation of test professionals. And I don't think daredevil is not necessarily a word that I even align with our older test professionals, the ones that were doing, the work in F-16s or even before then, back in the 70s. It was more like they were doing what they needed to do to make sure that we were being safe. And it did take a certain personality because there was risk involved. And that's something that I do fear, with the advent of technology and this foundation, it's really great because we're able to do things safely and effectively and efficiently, but it also can create a bureaucracy, a level of bureaucracy, and an organization that is unwilling to take certain risks, right? And so that tension and that balance is really important. We want to still be able to take risk, but we want to do it safely. And so how do we, match that up is a challenge, right? And I think with the technology, we can still take certain risks. And it's great to see, I think there are risks that are taken by Virgin and by Blue Origin because it's such an unknown space, but how do you do that smartly?
Sure.
Yeah, I think
one thing.
Sorry, I was going to say to pile on to that, Cinco. I think a lot of people, especially possibly the listeners here, are kind of conditioned by Hollywood to think that it is less disciplined than it actually is, right? And I definitely would parrot or champion your perspective that a lot of the stagnation that we've seen in the both aerospace community since probably really the days of the space shuttle has been largely tied to an extremely risk-averse culture. And that doesn't mean that we think you should become less safe in that. And there's a disciplined way to do that. But when you look at in the aftermath of the Cold War and the fall of the Soviet Union, we ceased to have an existential threat that was driving that risk calculus. And if you zap back to the 50s and 60s and really even into the 70s and 80s, there was an external pressure to force the risk calculus in a particular direction that just hasn't existed since 1991, right? And we see just from the acquisitions programs of stuff like the airplanes like the F-22, the F-35, all the way through the space program. I mean, I think since I was a kid, there've been a lot of grandstanding and discussions about how NASA is going to go to Mars and go back to the moon, and we've basically made no progress. And so I think the willingness of teams like Virgin, as well as just the commercial space industry in general, is really an important step in the right direction for our space program to get off of this subsidized approach that we've only used in the past.
Yeah, the question of
one thing that.
Go ahead, sorry, so you go ahead.
Oh, I'm just going to add one thing, kind of working at some of the edge of the human machine interface, HMI, and the development of that, is what one thing that you do see a trend of is that as things get more routine, we get more automated, right? And you do see that in the difference between what the platforms are from Blue to Virgin, right? The platform that Virgin is using, vertical launch, is something that is lends itself far more easily to automation, because there's simply a huge amount of data there relative to what Virgin has done. So, I don't mean to disparage anybody, but Virgin has done something that's a little more novel, to be very frank, than Blue. Blue is fundamentally standing on the shoulders of NASA, and so is SpaceX, right? With what they've done, and the 60 years of, or 70 years, I guess, at this point, of research there. Whereas looking at what Virgin has done, right? They took programs that had stopped in the 70s or perhaps the 80s, right? And picked up from there. Whereas a lot of the vertical launch continued to be refined. And it's interesting because, to your point, Animal, being an insider at NASA, one of the things they talk about a lot about is normalization of deviance and that risk posture, right? We lost 2 space shuttles. That's a traumatic experience. People don't recover from that. And if you look at it, one of my mentors, who unfortunately couldn't be here for this chat, Steve Schmidt, former associate director at Armstrong and at NASA Ames, had talked about this to me. He said, look, we go in 20-year cycles. You look at the difference between Challenger and Columbia, and there's this cycle of complacency. And I said, is that because is that because we're going too hard, we're trying too much? He said, no, it's the opposite. It's because we're not on the edge, we get complacent with automation and other things. And I found that to be really a profound statement. So I just feel that, given what you gentlemen have said, right, there is an aspect of keeping the edge sharp, right, that I think
that's right.
Virgin really represents.
Yeah, absolutely. I think in a lot of the stuff so I've spent a lot of time doing a bunch of autonomy things in Department of Defense. And I will tell you that it's very important to those of us that are close to those sorts of challenges to what we call not just trust the autonomy, but we want to properly calibrate our trust to the autonomy, right?
Right.
And what we're trying to, when we say that very deliberately, what we're trying to convey is that we need that edge, right? But we also need to very accurately know when do I need to retain the ability to come onto the loop to solve a particular problem. And I think I think exactly the sorts of comments that you make on Virgin, it's easy to overlook the fact that we have not spent very much time doing profiles like this. I mean, it was the X-15 and the F-104 days, right, that we quit back many, many years ago. And as a result, the amount of risk associated with those particular profiles and the fact that they are hand flying them, I think is an important motivator. It also is one that doesn't allow the team to get complacent, right? They suffered their share set of setbacks. Minnie's accident in 2014 on October 31st was a very emotional event for most of us who were part of the program and knew Minnie well, right? And it just highlighted the level of human involvement. And I never say human error because I really think that's a very pejorative term. I like to use the word human agency. Human agency does in the old days when our mechanical systems were not very good, human agency solved a lot of problems and compensated for a lot of, say, bad engineering or ignorance in the engineering of things. And over time, we've managed to engineer a lot of those sorts of aspects out so that most of the human agency is what drives a lot of the, say, fatal mishaps in aerospace these days. And so that's why there's an element of welcoming this autonomy, provided that we are properly calibrated in when and where to trust it, and when and where we need to step in and rely, kind of like we have historically, on human agency to recover the vehicle safely.
Animal, you mentioned you had to go. Do you have time for one more question?
Sure. Yeah, I am starting to get. They're going to come around and bug me here in a moment, but yeah, I can answer probably one more.
All right, great. At the beginning of the book, Nick describes a test flight where Forger intuits a solution to saving Spaceship 2 from crashing during an inverted spin by deploying the movable tail boom on the spaceship that is called the Feather. Does that sort of?
This is the one.
Sorry, go ahead.
This is the one where he feathered it when they shortly after the release.
Correct. Yeah. Does that sort of instinctive problem solving gained from years and years of experience make a good argument for keeping trained pilots involved in the loop in the control of a spacecraft, as you mentioned?
Yeah, absolutely. Right. I mean, I think when you look at it, in fact, that's probably one of Forger's best, probably the best example of why you want to have a capable individual. And the only way of really accomplishing that sort of thing is from experience, right? Whether you gain that experience, the only way to really gain that experience is not necessarily flying on autopilot for tens of thousands of hours, which is what a lot of our commercial airline pilots kind of end up getting lured into. And so, yeah, I mean, I think exactly situations like that where Forger realized he was in a set of conditions that they had not really planned for, and he was able to think outside the box, right? And essentially say, well, there is one thing that I have control over, and this is the feather mechanism that might help me regain control of the vehicle. So that's a terrific example of that. I think that's epitomizes Forger as an individual and his abilities to think on the fly. And I will say that although somewhat unique, that is something that I think we hope that a lot of our test pilots kind of going through the pipeline end up gaining experience along those lines. And that's kind of one of my concerns, I would say, just in general, if we go too much down the automated path, and if we say, if being a test pilot trades at a discount with regard to kind of astronaut selection and that sorts of things, because you'll definitely notice, NASA's not quite selecting in the same ratios of pilots and experience as they maybe used to do, certainly back in the early days of the space program. And so there is always kind of in the back of your mind the value that the premium that needs to be placed on that experience, because it's what really allows you to properly calibrate to the automation. It also allows you to deviate, and it gives you a good point of departure when the system doesn't behave the way that you expect. And so I think the successful recovery of that of Spaceship 2, that was back when they were scaled, right? Yeah. The successful recovery of that vehicle in that particular moment was extremely dependent upon that human agency that Forger basically brought to things.
And part of that too is despite the kind of the futuristic element of what they're trying to do, is also this very retro approach to doing it, which is that scale doesn't have a wind tunnel. So the only way that you can sort of replicate the only way you can sort of replicate or mimic max Q prior to lighting the rocket is to enter this really steep inverted dive, really steep dive. And I remember talking to Forger about that flight and him saying that it was the scariest moment, that it was the closest call he'd had. And I remember thinking, wait a second, you've thrown 3 subsequent rocket flights. You've got to be kidding me. And then when the glide flight came up again prior to them flight testing the current vehicle, and he was the guy who was going to fly the high speed glide. And he was like, oh man, I'm sweating going into this one. And I always found that fascinating that, you know, glide makes them sound sort of deceptively tame, but that these are the ones that you know, keep the best of the best kind of, you know, shaking in their boots at night.
Yeah, and I would reiterate that again, it gets into perception and our expectations. But in the flight test world, when we fly a brand new airplane, we do a bunch of high-speed taxi tests, right? I will tell you that the most dangerous things that we do are the high-speed taxi tests, which most people would have a very similar response to it. It's, well, you're on the ground, right? Like, why would you be that worried about that? The answer is that I'm eating up all this runway to accelerate. So I no longer have that runway ahead of me. I'm also, we tend to be very heavyweight, and we have very little knowledge about what the true aerodynamics are of the vehicle. And so high-speed taxi tests are remarkably dangerous, but deceptively sounding in that most people would think, oh, it's just a taxi test. No. Like these are conditions that most, you know, experienced test pilots know to be extremely aware and on your game for, right? And so I think that at times like that, you have to approximate conditions, which is what a high-speed taxi test is essentially trying to do. Or in the case of these glide flights, you're trying to approximate a set of conditions before you actually complicate it with, say, a rocket firing or something like that. And it actually, because that's the first time you're venturing into a region of the envelope that has the least amount of margin, which is part of the reason for why you're going there. It is the riskiest thing, and it's just not obvious to people who don't do disciplined flight test and are part of the community. So with that, unfortunately, I got to jump off, guys, but it's been terrific talking to you, and I wish I could hang on, but definitely thankful for the invite, and I got to go off to my debrief. So
yeah, thank you.
Yeah,
thank you so much for joining us, sir.
Yeah, take care. Bye.
Cinco, just to follow on that comment, I want to ask you, you know, for our readers, when they talk about in the envelope or for different flight profiles, they're talking about different parameters of flight, different aerodynamic conditions that lead to, that are things like very simple, cruising at a speed that we understand what the aerodynamics is, what the engines are going to do, and there are also the edges of that parameter space. Something, you know, and the most nefarious perhaps one is named as such at Armstrong. I learned to call it coffin corner. So, you know, Cinco, maybe you could just mention or you perhaps share a little bit of your experience of how you think about approaching tests in those types of parameter spaces, because clearly, you know, even though it was a glide flight, they were in that type of parameter space.
Yeah, it is, as Animal said, very dangerous in certain areas, and we've learned through experience kind of where those are. It's where people have died. It's where it's difficult to model the reaction, the aerodynamic forces with the structural, vibrational, like vibration, environmental aspect of our models are just not there yet. So that's why we have to flight test. We can't just predict it through computer modeling or CFDs, fluid dynamic work. So yeah, I think that for me and for our test profession, what we have is a mindset of being very deliberate with the way that we design test points. We want to do what we call a build-up approach. So you don't want to just go out the door on the first flight and go to 700, you know, calibrated airspeed to do a test point, right? You have to do an entire build-up to get to that point. Now, you can't hit every point, so you can, you know, pick and choose the ones that are the most important, that are going to garner you the data that can then be fed back into the model. And then the model now will update and allow you to kind of expand that envelope, is what we call it. And correct me if I'm wrong, I mean, I think of coffin corner as low and fast. And it's also high and fast. So kind of that edge of what we call an envelope. And for the listeners, imagine an XY graph where X is airspeed and Y is altitude. And the plane can go so fast and so low, so that's a corner. And it can go so fast and so high, and that's another corner. And you can imagine the rest. The dynamic pressure, the high Q, so high Q is dynamic pressure. It's the pressure caused by just having to go through the atmosphere. Like all those air particles are, and now if you're low, you have air particles and got a lot of water particles. It's thicker, right? So there's a point where it's max Q or high Q. And for us in the fighter community, the riskiest points are actually not usually the high and fast ones. They're usually the low and fast ones, where you're going, in the Eagle, we go 800 kcas, so that's knots calibrated airspeed, and we'd be doing that at 2,000 feet. And so there's so much pressure on the airframe that it is dangerous. So you build up to it, you work simulator missions, you figure out how to do, how to get there safely, how the communication is going to work. It's all kind of a scripted event. In the same breath, we have to do high fast. So I had to go clear a missile on the F-15C out to 2.5 Mach. And no one goes there. No one goes to these airspeeds typically other than test pilots, because it's very difficult to get there and you don't operationally need to. And so even getting to those points can be very difficult and require a lot of buildup. Like, imagine you want to go 2.5 Mach in an Eagle. Well, just go up to 50,000 feet and plug it into 5 stages of afterburner and get there, right? No, not at all. You have to start at 40,000 feet. You have to descend to 38,000 feet, get to 1.1 Mach, climb to 44,000 feet, accelerate out to 1.3 Mach, dive again down to 36,000 feet, get to 1.6 Mach, and you do this roller coaster just to get to 2.5 Mach at 50,000 feet, right? And so it is a process, once again, a team effort to ensure that we can get to those points, get the data that is required, and then safely, get there and come back.
Which and even just that account, it just gives lie to the notion that test pilots are sort of spontaneous and just figuring it out as they go along. I mean, it's like as you described it, it's so rigorous, and I think that was one of the things that I found as an outsider fascinating. I mean, as Animal was talking about the high-speed taxis, I'm thinking about the challenges. I've not seen I think few people besides maybe the English national football team or soccer team was able to see Top Gun 2 before the final or something I saw. But like, I was thinking, how do you render a high-speed taxi test sexy enough for Hollywood? And that's a tough one to do. But that's the reality of this world, which is like, how do you capture the moments that are not the ones that we associate as being sort of sexy and dramatic as being the ones that are actually the most challenging? And I think that's really interesting. And I think was one thing that I tried to kind of to screw down on a bit. That's really I love the kind of this stair step notion of getting up to where you need to get, and not just pointing into the stars and putting on the afterburners.
Yeah. One piece of the book too, Nick. So Leif Erikson is portrayed in the book, and I know Leif and I respect Leif. And there's an interesting tension that goes on between Forger and Leif, and it's almost a mentality of like one is a cowboy, and one is too risk adverse, right? And that's tough, because I almost sided. I understood Leif a lot when you portray some things that he said. And how they wanted to make sure that they were being safe, and how do you smartly take those stair-step approaches. I found myself being like, yeah, that's how we need to do it. But then you also have that other side where it's like, well, but you can't be too risk adverse or you're never going to get there, right? You're just going to iterate and engineer the crap out of something, and you'll never actually deliver on the capability that you need. And that was really, I think it's important for listeners to know, and the readers too, that what Leif was bringing up, I think, are valid, really important points, and I don't fault him for any of that. And so, how do you make sure you have that mentality while you're still able to accomplish something that is extremely, novel, new?
Totally. Well, and I think anecdotally, secondhand, I mean, I gather that some of the pilots didn't appreciate their characterization in the book. In some ways, looking at Todd Erickson kind of is vindicated, right? And because he's the one who also, he expresses these concerns. Then there's the delamination after the February 2019 flight that grounds them for more than 2 years. And and Todd's the one saying like, this is a big deal. We should not treat this as an isolated incident. This is a reflection of our safety culture, et cetera. And obviously the story is told from Forger's perspective, but no, I thought that those two huge personalities, both of them very self-confident, both of them very experienced, and watching that sort of philosophical battle over flight test, over commercial flight test, and how different is that from a military flight test program? Would you be having those same discussions? Hey, we're 17 years behind schedule. The boss is on MSNBC again yesterday saying we're going to be in space in 6 months. Like, you don't have those sorts of concerns in the government side. And how does that influence a test program? And I don't know the answer. I don't know if that's a healthy tension or not. To kind of add some urgency. Go ahead, Zeke. Sorry.
Oh, I was just going to say, this has been an amazing discussion. One thing that I just might add to that, having watched this tension between the safety culture and the go mentality, at Armstrong, typically the director of operations does a turn as the director of safety before becoming director of operations. That's a long-standing tradition that helps inform the way the operations, where engineering and test and all that stems down from, is to drive the safety culture into it. But you bring up a really important point that in a government program like NASA, you may not have the pressure of the boss on CNBC, but there used to be, as Dan pointed out, a very different pressure, the pressure of national security, right? Coming from the nuclear world, there's a lot of things that are very classified, that are done at extreme risk to individuals, and that are accepted because this is what's necessary to make the world safe. What I think might be happening, and so one can actually say that perhaps a commercial program should accept less risk. So this is an ongoing conversation. I agree with you that this is not something that's going to be solved now, but I think Test Gods is going to be a seminal work in really examining that, because it really opens the door to the rest of us, or to much of the world, to the listeners here, into that world and how it works, how that evolves mentally, and in particular, how it evolves in the commercial sector. So, just spectacular stuff.
Yeah, the question of, is it worth it driving test priorities during the Cold War and not having that question hanging over government programs now, and you have the commercial urgency driving private programs, and I think that's fascinating. And I wonder, getting back to kind of NASA culture, I do wonder whether, people have asked me what my sense is that NASA is sort of happy to see the suborbital. They're not threatened right now by anything Blue Origin or Virgin Galactic is doing. They're happy to kind of see the lower hanging fruit to them, and to focus on deep space exploration, et cetera.
That's right.
But as SpaceX develops its capabilities, SpaceX needs the government, has needed the government to get to where it is. At some point, will SpaceX be seen as a competitor and not as a peer to NASA? I don't know. I don't know enough about, 98% of Test Gods is focused kind of on ground-based flight test programs. I don't know enough about the culture and the bureaucracy at NASA and even SpaceX to know. But do you see a point in which NASA views SpaceX as more of a rival than as a peer, as a partner?
I actually think that's never going to happen, because most of us in the NASA community are saying, thank God. Thank God for these guys. Yeah, this is great, right? Because what it's doing is it's right. If you remember back to the 70s and 80s, the shuttle program was supposed to provide a launch platform for satellite placement that was going to be cost effective. It never achieved that. It never achieved that. It was always too expensive. And it was supposed to be cheap, a cheaper platform than the typical rocket to direct, right? It was supposed to, the reusability of that. Now, of course, the demonstration, the learnings, the amazing science, the Hubble repair, we can go on, right? It was a great success, but it didn't meet that success criteria. SpaceX answered the NASA Grand Challenge from 20 years ago, which was to reduce the cost to orbit by a factor of 10. Take it from 20,000 a kilogram to 2,000 kilogram. That's going to blow the door open. So from the NASA perspective, we're like, holy, this is great. Somebody has solved this cost problem. Now we can put up anything we want because it's literally a factor of 10 cheaper. Otherwise, you look at, observatories. Hubble is shown to be, Chandra and all these observatories are shown to be, oh, they're really inexpensive missions. That's only if you don't count the launch vehicle cost, only if you count the payload cost. As soon as you amortize the launch vehicle across it, they're ridiculously expensive. I'm not saying they weren't worth it. I 100% believe they were worth it, but the cost is, there's a bit of a spin on the cost, right? SpaceX changes, and their success, Blue Origin and now Virgin, is completely changing that. I can imagine, the Virgin platforms becoming amazing vehicles for all types of human life support research, right? With different flight profiles, et cetera. So what this is doing is this is enabling NASA to do what it's supposed to do, which is be on the bleeding edge, which is go do the thing nobody else can do, take the risk that no corporation will take in the early technical readiness levels, but a government will take that risk. That's NASA's role, right? To me, this is a great example of what government and industry, feedback loop is supposed to be like. So, from the NASA community, not rivals. We're super happy for them. Their success is our success.
Yeah, I get a sense too that our national security actually depends on silos coming down, right? If we want to be able to continue to defend individual liberty, right? We need to make sure that we're working with industry more so. We should be buying commercial solutions more so, right? The world with emerging technology, the agility that is required, the cumbersome acquisition, process of the government, like there's different aspects of this that require us to learn to lean on industry even more, and get out of the business of trying to create ourselves when the solution is out there. Like I don't know enough about it, and this is just me, my personal opinion, but I feel like the SLS conversation is kind of a piece of that, right? Like, should we be paying NASA to develop this own rocket using that money, or should we just rely on the Falcon Heavy, right? Like SpaceX has already solved that. So where is that intersection of making sure that we rely on industry the right amount? But it is a challenge because there's certain things that we want control of. Like, I don't want Microsoft or Amazon or Google like running the battlefield. Like, they're engineers. Like, we need to own pieces of national security defense because it needs to be the nation that is making decisions of life and death, right? And so we want to make sure that we have the right aspect control, but leaning on industry for the other.
Right, and the FAA might be a great example where you could put that out to industry possibly, but at some level we want those people accountable in a different way. You look at the way the nuclear industry works. When I've signed as a nuclear safety officer calculations for an operation, right, I'm not only liable through the organization, I'm personally liable, right? I can go to jail if somebody dies, et cetera. So there are things we want accountability built in. And so when you go to commercial organizations, right, there is a distribution of accountability, right? That's part of their business model. That enables them to make money. Is they manage risk, right? Cars are only recalled when the actuarial tables say that the lawsuits are going to cost less than are going to cost more than actually repairing 10,000 vehicles, right? So those are commercial decisions. So one can imagine that with that, the SLS is a traditional buy versus build discussion. So we'll see how that evolves. What I think, and this is not me speaking on behalf of NASA, but me speaking on behalf of Zaheer, right? So I just want to be clear about that, is that there is going to be this tension indefinitely. Because it's a continuum. It's not a discrete point, but Cinco's point about national security and being a driver in the commercialization of technologies is a really important point. And I think it just goes back to the risk, right? governments can take certain risks, particularly financial, that investors simply will not support a commercial organization to take, right? It's not an accident that the people who have driven the space race are people who have fundamentally put their personal fortunes at risk. These are not shareholder-driven companies. I mean, they are now, a couple of them, but, right, Branson, Bezos, and Musk put their personal fortunes into these companies, right? And that is something to really remember and differentiate between the way a privately held organization works versus a shareholder held organization. Whereas government has, the US government has 80 million shareholders, or 320 million shareholders, right? Sorry, I was thinking, of California and Nevada and the Southwest, right? So there are drivers there, right? Whereas with the commercial, it's a little different.
So Nick, there's a really interesting theme throughout Test Gods, which is this theme of space travel being a humanistic endeavor versus space travel being a militaristic endeavor. And to me, it's present from the very get-go with the story of Forger watching John Glenn's flight as a 3-year-old and his father, who's a pacifist Mennonite, telling him that he would never allow him to do that. Yeah. When you're describing Jack Fisher's decision to leave the astronaut corps and help stand up the Space Force, you say, quote, "Space travel, despite its comradely and humanistic overtones, had always been a quest for military dominance," unquote. In the past interviews, you've said that you wonder whether or not Virgin will be able to make this a really viable business model, the space tourism business model. Do you think that despite their humanistic overtones, Virgin might only be able to survive if they embrace some of the militaristic aspects of spaceflight?
Well, that's a good question, right? So I think that they made a very wise calculation a few years ago to cleave Virgin Orbit off from Virgin Galactic, therefore limiting some of the liability if there was an accident in Virgin Galactic, and also opening themselves up to government contracts on the orbital side. I think, look, it's no sort of great revelation that government money is good money, right? And I think that Virgin Orbit realizes that that can in some ways sort of also support. I mean, now that Virgin Galactic is public, there's no shortage of cash on the runway to kind of allow them to continue to develop. But Virgin Orbit does offer some stability, I think, and financial stability, and it also there's a lot more sort of there's a lot more potential there as a business. I mean, I was struck just image-wise. I've spent one day at SpaceX headquarters, and I was struck by the number of military officers, uniformed officers coming in and out of that facility, not as guests, but as fully badged, badging them their way in and out. And I'm not trying to sound conspiratorial or anything. It's clear that the way that government and private and public, military and private are working together very closely at SpaceX, and it in some ways just kind of reinforce some of those themes that those two partners are kind of joined at the hip in some ways. But I don't know. But to get to your question, I don't know. I mean, there was some reporting a couple of years ago about the Army Chief of Staff, David Goldfein, being interested in using Virgin Galactic technologies to be able to kind of transport special operations teams anywhere around the world. I think that we're still a long way away from that being a reliable capability that the U.S. government and the Special Operations Command is kind of ready to rely on and depend on. So.
Gotcha. Well, we're just about out of time. You've written a fantastic book in Test Gods, and I think it's going to be going to go down in history as the same way that the Right Stuff did for the golden era of flight test and the beginning days of space flight. I once heard someone say that a journalist's job is not to tell people what to think, but to tell them what to think about. What do you want readers of Test Gods to think about?
Yeah, that's a great question. I I think that one of the biggest revelation for me, I think, was that ultimately all of this, despite all of the kind of the commercial potential, the national security potential, it really is a story about inspiration. And I think that that is one of the awkward revelations in the process of writing the book, which is that I came to this book very much as a cynical DC-based journalist and kind of, wasn't ready to impose any kind of grandiose notions on top of on what I was seeing. And in the end, you asked me at the very beginning about kind of my relationship with my dad and how that influenced and it changed the way that I interacted with my kids and how I kind of thought about what my role is as a parent to inspire them. And to hear people like Burt Rutan talk about the importance of what Spaceship One was. It was that, yeah, they won the X Prize. It was fabulous. But what it did was it inspired a generation. His big indictment against NASA has been like, what have you done for me lately? What your role is to inspire, is to shoot, the moonshot is an inspirational thing as much as it was a national security priority, right? And I think that that takeaway, like finding a little bit of kind of awe and wanderlust in what is, generally speaking, a pretty cynical world at the moment, was, I think, one of the more refreshing takeaways for me.
Well, that's a great note to end on. And Nick, I want to thank you for taking the time to join us. And Cinco, Z, this has been a fantastic talk. At the end of the book, there's a quote from Forger giving a speech to his high school alma mater where he says, quote, "The real impoverished are those whose minds and willpower are insufficient to commit to chasing their dreams." And I think that's the perfect note to end on.
Thanks, guys. This has been a lot of fun. I appreciate it.
Thank you.
Well, folks, thank you very much for joining Space Talks. It has been a true pleasure. Check out, I'm just going to share the screen, my screen real quick to show the cover of Test Gods. Please go ahead and grab this. You are not going to be disappointed by this book. It is going to be one that you hand your kids someday. A story of inspiration, grit, and everything that makes humanity great at a fundamental level. It's told by an amazing storyteller in Nick Schmidl. Cinco, thank you so much. We had Animal Forchik on with us earlier, Ben McNally, and of course, Nick Schmidl. Thank you all very much for joining.